Hi everyone, we are going to now at least start our last unit, and our last unit is financial applications. So this is where our real life situations come into play, and this is where you hear a lot of people, I wish I learned that in school, and we are going to learn a little bit about it here. We're not going to get too deep into it because we're running out of time, but I wanted to introduce financial applications to you. So first of all, we want to take a look at how interest is calculated. So there are a couple of different types of interest. Simple interest is just that. It is the fact that interest on an investment or a loan is calculated only on what we deposit. So interest is calculated only on the principal, and the principal of an investment is simply what was deposited. So if we are calculating the principal on an investment, we are figuring out the interest only on what was deposited itself. Compound interest works a little bit differently, that after each time period, we now add the interest that was earned into the principal. So interest is calculated on the principal and interest previously earned. Okay, and we're going to take a look at how it changes what we have in our investment. So $1,000 invested for 5 years, 4% per year, and per annum simply is the Latin way of saying per year, financial way of saying per year, and we're looking at simple interest. So our principal for every year doesn't change. It's going to be $1,000 every single year. Interest earned, we can calculate, remember we're going to change our point or our 4% to 0.04, and when we do that, we're going to get $40. And at the end of the first year, that means that we have $1,040 in the account. Well, the next year, it's exactly going to be the same because it's only calculated, interest is only calculated on the $1,000. So every year, same thing, as long as we don't change or touch the account, there's going to be $40 added into the account. So our amount, or what's in the account each year, goes up by $40. So at the end of 5 years, we would have $1,200 in that investment. Now, notice that this is linear growth. We have the same amount going into the account every single time. Now let's take a look at how that changes with compound interest. So this year, or this time, we have $1,000 in the account to start with, and we're still going to have that $40 interest. So after the first year, it's exactly the same. Now, the second year, though, we now have $1,040 in the account. So interest is calculated as 1,040 times 0.04, which means that we're going to have $41.60 in interest for that year. Again, we add that into our account, which means that we now have $1,081.60 in the account, which becomes the principal for the next year. Again, 1,081.60 times 0.04 means that we get $43.26 added into the account. adding that into our amount, that means we have $1,124.86. If we now take a look at that amount, multiply it by 0.04, this time we get $44.99 in interest and $1,169.85 in the account. And for our last year, that becomes our principal. When we calculate our interest, we get $46.75 in the account, which means that we have $1,216.60. Okay, so we can see that we have in simple interest, it's the exact same investment, $1,000. Simple interest, we had $1,200. Compound interest, we have $1,216.60. So we have an extra $16.60. So that $16.60 is simply the extra that is earned on the previous interest. So if you're investing, you want it compounded. If you're borrowing, you would prefer simple interest, but traditionally most investments and loans are compound interest. And the more often you compound, the more interest is going to be earned, and we'll talk about that in a second. Example number 2. So now we want to take a look at the investment of $1,000, and we're going to make this 4%, the same as our previous, but for 25 years. Well, we're not going to do this for 25 years. So we want to come up with how we're going to do this. And remember, when we took our $1,000 at the beginning, we multiplied by 0.04 to get our interest. Well, if we wanted to go straight to our amount, we could take our 100% that we started with plus the extra 4, which means that we have 104% of what we started with, which is 1.04. Well, that means that we could take our 1,000 times 1.04 to go straight to our 10,040. To go straight to our second step, we multiplied by 1.04 twice. And checking in our calculators, we get 1,081.60. And we could keep doing that for the number of years that have passed. And again, checking that out, we get those numbers that we had above. So we're going to take our $1,000, our amount that we have at the end is going to be our $1,000 times 1.04 to the power of 25. And when we do that, we get 2,665.84. So our amount is 2,665.84, or what is in the account at the end of 25 years. Now, looking at this, we can do this for any compound interest investment. Our formula is the amount is equal to the principal times 1 plus I to the power of n. And what these mean, A is amount or end value, P is our principal or beginning value, we can also call that the present value. I is our interest rate per period. And we'll take a look at what that means in a second. Sorry, interest rate per period. N is the number of compounding periods. Which means number of times interest is calculated. So, first one we have here, the amount we want to calculate the amount of the investment and the interest earned. So we'll talk about interest in just a second. So A equals P times 1 plus I to the N. Our principal, we started with 3,000. Notice that this interest rate per period, a 1 gets put in front of it every single time for the initial 100%. So we're going to have 1 plus and 8% per year. This is compounded annually at the end of every year. So 0.08, and for 7 years, meaning that we're going to calculate interest 7 times. Simplifying that expression, we're going to have 1.08 to the power of 7. When we put that into our calculators, we get $5,141.47. Now, interest. Interest is simply the difference between what we have at the end and taking away what we put in to start. Because the only difference in between there is how much interest was added into the account. So here we're going to have $5,141.47 minus the $3,000 that was put into the account. So $2,141.47 is interest. So the amount is $5,141.47, and notice our dollar signs and our 2 decimal places, and interest earned $2,141.47. Okay, so that's compounded annually. We don't have to change our I or our N. Now, interest is compounded sometimes more often than once a year, so we have to account for that here. So notice that this is compounded semi-annually, so every half year or twice a year. So again, still starting with A equals P times 1 plus I to the power of N. Principal is still our 3,000. But what we have to do here is, because we want to know what the interest rate is for half a year, we're going to divide the I by 2, change it to a decimal and divide by 2. And we also have to now multiply our number of years times 2, because interest is going to be calculated twice a year. Simplifying our expression, 3,000. When we take 0.08 divided by 2, we get 0.04. We add that to the 1, and we're going to have to the power of 14. When we do that, we get $5,195.03, and our interest, difference between what we take out and what we put in, means that we earned $2,195.03 in interest. And again, notice that that is greater than our $2,141.47 that we earned in the last step, a little over $54 or 53 and change extra interest from compounded annually. So you can see that compounding twice a year because you're earning interest on that interest that was earned after the half year, in the second half year, and so forth. Part C, again, starting with and I'm just going to do a therefore statement to save a little bit of time and get you started on your work a little bit quicker. So our principal in this case, $1,500, and our interest rate, we're going to change to 0.05. Notice that this is compounded quarterly. So every quarter of a year or 4 times a year, meaning that we're putting in, or we have to divide by 4. Our interest rate is only for 1 quarter of the year. So we have to change the interest rate to a quarter of a year. And the number of times we're going to calculate interest, 6 years and 4 times per year. So again, simplifying this calculation, we are going to take our 0.05 divided by 4, gives us our 0.125, and we add to 1, and we're going to have to the power of 24. When we do that in our calculators, we get $2,021.03, which means that our interest is going to be our 2021, what we have at the end, subtracting what we put in. So we have $521.03 in interest. And again, we'll do a therefore statement just stating exactly that. And our last one here, we have $1,500 invested for 5 years at 18.5% compounded monthly. So 12 times a year. Okay, quarterly 4 times per year. And semi-annually is 2 times per year. And we have to adjust appropriately. So we have our principal of 15,000 times 1 plus, and our 18.5% becomes 0.185, and we're going to divide that by 12. And our N, we have 5 years times 12 times a year. So simplifying, and we could do this all in one step on our calculators. 0.185 divided by 12 gives us our 0.015 plus 1 gives us our 1.05, and then to the power of 60 times 15,000, which gives us $36,648.30. And again, our interest, difference between those two amounts, taking away 15,000 means that we have $21,648.30 in interest. And again, in our therefore statement, we're going to state, therefore the amount was $36,648.30 with interest of $21,648.30, making sure we have our 2 decimal places and our dollar signs. Okay, so we should be able to calculate our interest. If you can't round this or your interest rate per year divided by the number of times a year evenly, again, you can put it all into your calculator in one step, taking that, figuring it out, adding to 1, then doing your exponent and multiplying by your principal, or just keep a bunch of decimal places. You can simplify